I'm going to go through a few of these problems, just a couple to show you how to do it. This is just your algebra review. So if I was to solve for R, and I start with PV equals nRT, the gas law, and I want to solve for R, I'm going to divide both sides by N and T, which isolates R. Whatever I do to the right, I do to the left. So for R ends up being equal to PV over NT. Now I was having a little bit of fun of this when I asked for 1, solve for 1. If you started with PV equals nRT, and again, I would always show my work somewhere on the paper. Well, if I want to solve for 1, how do I make P times V equal 1? You divide it by P times V. So 1 is equal to nRT over PV. Now, I could have also said PV equals nRT, and if I wanted to make the right side equal to 1, I'd divide it by nRT. Cancel, cancel, cancel. So 1 could also equal PV over nRT. So 1 equals PV equals nRT, or 1 equals nRT over PV. Okay. When I was at R, if I put these together, and that's what I did, is once I set it for 1, I said, well, let's just link these two. Well, if N and R are constant, they're going to cancel out. And it leaves you with the combined gas law. Okay. And so I'll just solve for one of these. Let's solve for number 9, T1. I want to solve for T1. The first thing I see is it's on the denominator. Well, I want to put it on top. Well, if I put it on top, that means I'm going to invert it. So I just take the inverse of the left side. Well, I can take the inverse of the right side. That's equal to T2 over P1 V1. No, 2. And then if I want to isolate T1, I'll multiply both sides by P1 V1. And sometimes you just say, well, if you're doing algebra and everything is multiplied and divided, if it's on the bottom here, it's going to show up on the top there. If it's on the bottom on the left, it's going to show up on the top on the right. That's because I'm multiplying this side by T and D. Okay, so your solution for T1 is equals T2 P1 V1 over P2 V2. Most common mistake, students will look at this and they'll divide both sides by P1 V1, and they'll tell me that T1 equals P2 V2 T2 divided by P1 divided. Well, once you divide by that, you end up with a 1 on top, and you're not solving for T, you're solving for 1 over T, and that would be a mistake. And I was having a little bit of fun down here, just deriving the gas laws from the same equation. If I tell you to, starting with the combined gas law, okay, if I keep the following things constant, what's the solution? Well, R and T are already out when I brought it to combined. So if T1 and T2 are constants, that's Boyle's law. And this just states Boyle's law, that P2 V2 equals P1 V1. Okay. And I had a little bit of fun down here. You may see a problem like this on the SATs, and this might send a person into circles. If you started out with the combined gas law, if I ask a student to solve for P1 V2, P1's always going to be in the numerator up here, and if I bring V2 on the bottom, it'll end up on the denominator. And as people start doing this, that'll drive them crazy. So the first thing to do is, you do get problems like this on the PSAT and the SAT. So it's just sometimes you have to think outside the box. First I'm going to solve for P1 individually. So I'm going to divide by V1, divide this side by V1, and I'm going to multiply by T1. Okay, and so I'm going to multiply this by T1. Now I stop right there. No matter what happens, if I try and get this V over to the left, it's going to end up in the denominator. Well, I want it to be multiplied by V2, so all I got to do is think outside the box and just multiply it by V2. Well, that equaled P2 V2 T2 T1 T1 V2. Well, if I multiply this side by V2, that means I'm going to multiply this side by another V2. What I end up with is V2 squared. And that is your outside the box solution. I think you could also solve for V1. Now, you could take this side to solve for V2. One of my students showed me this one time. And I was a little insistent that I was right. But she looked at it a little differently. And she said, I'm going to solve for V2. So P2 ends up on the bottom. Divide both sides by P2. T1 ends up on the top. And now she's got V2 equals this, and then she said, well, I'm going to multiply both sides by P1. And her solution was that P1 V2 is equal to P2 square P1 squared P times P is P2 squared is P squared, and then times T1 V1, then divided by P2 T1. And the answer is also correct. So there were two correct solutions, and she taught me something to not be so insistent that I was right, because I would always do it this way. So there are two solutions to that problem for number 16. All right, very good. I just showed you that because the SAT test will do that to you for algebra. They'll give you something that sometimes you have to just think a little outside the box. And if you got a little bit of confidence and swag, your algebra swag, you'll always be correct.